Okay, we left off talking about all the ports. Okay, that was the last thing we talked about last time. Okay, now let's start talking about addressing. Okay, it says TCP/IP addressing is a long, complicated numbers. Okay, actually compared with IPv6, these are quite short. But still, a lot of numbers are very hard for people to remember. Okay, it's good for computers to understand, which makes it nice. But for us, it's tough. Okay. We remember words better. Do y'all agree with that? So many people nowadays, you ask them what their phone number is, and they're like, I don't know. I don't even call myself. I'm like, dude, has anyone got the problem in here? The one to admit it? The opposite. You remember numbers, not names? I don't know why. Well, that's good. That's really good. Yeah, a lot of people better with names, so we come up with DNS to handle that, and that's what this starts about. Okay? They talk about a host, first of all. A host is a computer. It's a device. It could be a printer. It could be a smartphone. Anyone get the iPhone?
Where's yours? Android.
It's right here, dude. Android. No, I taught class Saturday morning. I didn't stay in line or nothing. A student who works here calls you, all right, I got your phone, come get it. I'm like, sweet. Okay. But I didn't pre-order nothing. But Saturday I come in to teach a bunch of high school students. And teaching on Saturday, I got 50 students. And they weren't talking. It's like, y'all sleeping? I said, I know what it is. Y'all stayed up all night getting the iPhone, didn't you? They were laughing. But no, it's no. Also phone, you should get it. 11 meg download. It's really good. I love it, yeah. And I've driven with the maps, and I've had no issues with it. Now, which I-40 sucks, like all GPSs, because I-40 moves, so now you're driving through a cow pasture, you know. That's normal for a while. But the cool thing is they can actually update this one. So, all right. Even Google's still wrong on that part. So.
Turn right here.
Yeah. What now?
Turn right here.
Yeah.
Okay.
That's like, take a left on 5th Street. Take a right on 6th Street. Go straight. It's like, dude, there's like nothing here.
On the interstate.
Yeah, it's kind of cool. But, all right. But a host is an internet device. And so pretty much can be anything. It could be a camera, it could be a phone, it could be a printer, it could be a computer, it could be a gas pump. Okay, I remember when Sam's, you know Sam's over here, I don't know what Sam's is, they switched to frame relay. Basically, they switched their provider. And who's messaging me? Okay. They switched their provider. That was right when the internet was starting to get fast. Prior to that time, whenever you use your credit card anywhere, you know, it was the wait 30 seconds while it dials up. Some of them you could hear them dial. The other ones you couldn't hear them, but it still took a long time. But I remember they switched to their new internet provider, which was Frame Relay at that point. And it's like you swipe your credit card and the receipts come out. You're like, wow. And so I remember when it just started to get fast. But now everything can have an IP address on it. They're talking about more and more things getting that way. My solar panels got IP addresses on them. You know, everything does. So kind of handy. Okay. A name is the name we know it by. So if I was going to go to www.google.com, what's the host name? Anybody know? Actually, the host is www. The domain is google.com. The host is always the beginning part when you're talking about a domain name. Like mail.google.com is the mail server. www.google.com is the web server. Now, is the machine actually called that? Probably not. It's probably called web server 01B or something. But for the outside world, we know it is www. Okay. Now, a lot of sites, you notice you don't need www anymore. So what does that mean? They don't have a host? Just defaults to www. It's for lazy people. When I was doing DNS for my ISP, that's all it's for. Lazy people like, oh, I want my website to work without www. I'm like, okay. I mean, I can do that real easily. It's because people don't want to type it. It is, and plus a period. Okay. But did y'all know, like, if Google's like your default search engine or something, you don't even need to go to Google. You can just type your terms up on the address bar and hit enter. Y'all know that? You have to go to Google. You just type it in there. I had a client of mine, Chapel Supply. They sell pressure washers. All kinds of cleaning equipment. Pressure washers, tanks, everything. They called me one day and says, Ken, my website's down. Can't find it. I'm like, what do you mean you can't find it? I bring it up, it's working fine. He goes, nope, can't find it. So I drive across town. So what do you mean? Well, all he had known to ever get to his website, he would search for it in Google. He never knew you could actually type it in. I'm like, well, type in chapelsupply.com. It's not there. Well, that's what, he was searching for it. Somehow it got moved lower down in the search engine, so he didn't see it. So instead of being number 1, it was like on the second page or something. And he's like, it's not there. I'm like, I said, you know, you can just type it in the address bar. He goes, you can? A lot of people don't realize they think you have to search. But if you know where you're going, you can just type it in. So, kind of crazy. All right. So, domain name is a group of computers belonging to the same organization. We have the rose.edu domain. It's the Rose State domain. It's a bunch of machines below that. We got mail servers, print servers, web servers, file servers, everything underneath the Rose domain. Okay. They share a common part of an IP address, which we'll talk more about. Okay. The domain name is it's how we identify it. LOC.gov, rose.edu, google.com, whatever. Okay. Now, does that have to does www.rose or google.com have to point to one machine? No, it can actually point to many. Remember we did that quiz, and it was like 5 or 11, however you came up with, different machines it could be answering. Okay. It could be associated with a company, a university, a government organization. It could be anything. Okay, just about anything. Okay. A fully qualified domain name is now the host, including the domain. So here we got blogs, which is the host, with the domain loc.gov. So the fully qualified domain name is now blogs@loc.gov. Okay? It's the host plus the domain. Can there be more in there? Could it be like blogs.east.loc.gov? Sure, we could. Sometimes you'll see names that have multiple parts to them. Okay? That's just the basic name. All right. Label. Character string separated by dots like google.com. It's how we see it. It's just, I don't know why they call it really a label. It's really just how we see it. Okay. The third level domain, the top level domain is com. Okay. I'm not third, the top. The .com is actually the top level domain. Do you ever hear something called the root domain? There's actually something called the root domain. That's just a period. Okay. Because what happens, the way DNS works, say I want to go to google.com. And I've never been there before. Okay, so I don't know anything about it. First thing I do is look at my machine. I look at my own machine right here. It says, am I Google? No, I'm not Google. So then I ask my DNS server and say, hey, I'm looking for google.com. And my my DNS server down the hall says, well, let me look. Am I Google? It says, no, I'm not Google. So then it puts a request out. Okay. Say this is the very first search it's ever done. Okay, so there's no cached entries, no nothing. It doesn't know where to look. So what it does is it sends a request to the root servers, the period. There's 13 root servers out there, by the way. A couple of years ago, 11 of them got taken out by hackers. Still ran fine. So worldwide, there's 11 of them. And all they do is they tell us where the .com, the .gov, .edu, .net servers are. So when we wanted google.com, my server says, I don't have a clue where it is. So it asks the root servers, hey, who's in charge of .com? So then they return a response to our DNS server says, oh, .com is this server, wherever that one is. I don't know where it is. Okay. Then we ask the .com server, we say, hey, since you're in charge of .com, who's in charge of Google? So then the .com servers, the top level domains, says, oh, you're looking for Google. You're looking for the second level domain Google, and that's over there. So they forward us onto the Google server. Then we ask the Google server, hey, since you're now in charge of Google, where is www? And the Google server says, oh, www is over there. So basically, it's a multi-step process. But our servers actually do what's called caching. Once they find the root servers, and the root servers tells them where the .com servers are, we remember that for a while. You remember stuff for a while? Same thing with computers. We remember a certain period of time. Do you think a computer should be able to remember them forever? They probably could, but we don't want that. Because the cool thing about the internet is you can be one IP address today and a different IP address tomorrow. Because they can change. And those records, those results we get back for the DNS service has an expiration date on them. Kind of like the milk you buy in the store. Well, the DNS requests come with an expiration date. They say they're only good for 2 days or 8 days or 3 hours or 10 minutes. When I used to do my server, I usually set off for about 8-day expiration. But when I know I'm going to be doing some work on it, because I always schedule this stuff, I lower them to about 3 days. Then I lower them to about 1 day. Then I lower them to just a couple minutes. Then I knew I could go in and change it, and anybody who was asking for that, I knew those records were going to be expiring within minutes. So even if you ask me for Google right now, the moment you got the information, you're going to give it out and then expire the record, delete it. Then you're going to have to ask me again. So it caused a lot of traffic on my end, but at least they were getting the updated information. Kind of understand what I'm talking about? Okay, so it's kind of, I don't really go into it too much in here, but okay.
So when you say there's 11 root servers,
Yes.
is that for the World Wide Web?
Worldwide, there's 11 root servers.
Or the www?
No,
Or
for
the overall
.com,
internet?
.edu, .org, .net. These are like the main places that says, okay, if you're looking for .com, see, .com is managed by one area. .edu is managed by a totally different area. .org by another area. .net by another area. Different companies are in charge of these top-level domains. Okay, the root servers tell you where they're at. Okay, so the root servers say, hey, if you're looking for something that ends in .com, go West Daniel.
11 of them got taken out, and it's still ran fine. It has to be open.
Oh yeah, all 13 of them know all the information. Those 13, all they do is hand out the address for .coms, .edu, .org, .net. They don't do anything at the second level. All they care about is the first level. So if you took out 11 of them, you've got 2 more to go. So the response might be a little slow. Yes.
So when the Iranians create their own internet, they have to come up with their own root server.
Okay.
They won't be using those 13, is that right?
Actually, if they're, it's going to be on the, I mean, if they're going to have an internet connected to the rest of the world.
Did you hear that story?
No, I didn't hear that one.
They want to create their own self-contained.
Oh, some people, they want to block Google and everything.
They want to create their own self-contained Iranian-only internet.
Yeah, they'll have to get their own root servers.
We don't go and mix them or whatever we did.
Oh, nice.
And to keep the people from,
Yeah, they will have to get their own root server, their own top-level domains, their own they'll have to get their own everything. And it's a big deal. See, before DNS, way back when this first started with ARPANET, this was all done what's called a host file. Just one file on a computer. They're still there. We'll look at that. The host file was still on our machine. And there's actually a virus out there that would edit that host file. Because what the machine does, it basically looks there first. It says, first of all, am I Google? No. Have I ever been to Google? Or do I know anything about Google? It looks in the cache. Then it looks at that file. And so if you can get in and edit that file, like downstairs our secretaries years ago when MySpace was the popular thing, we had a couple different secretaries, and that's all they would do. I mean, you go in and need some travel paperwork done, like, here, I need to get the travel. Just a minute. Come on, 2 hours later, okay, I'm almost done. She's on freaking MySpace all day long. So I got permission, and I went in and edited the host files on both secretaries' machines. And I made MySpace and all those point to RoState's website. So when they typed in www.myspace.com, went right to RoState. And the funny thing was they didn't complain to anybody. Can you imagine complaining, hey, I'm at work during my work hours trying to surf MySpace and it's not working? Yeah, no one's going to complain. But I got permission, like, go for it. And actually, all the computer labs were set up that way for a while. But they finally turned all that off. I mean, I wasn't blocked, I was just redirecting. Because the way the name resolution process starts, the host file checks if you are Google, but you're not. Checks if you've ever been there and remember it. But if you don't, next thing it does is checks that file. Then it asks the DNS servers. So if you can get to that file, you're sweet. Because that file's been there since day one of the internet. So that's how they always worked. Okay? All right. So ICANN establishes the naming conventions. They have new ones now. .sex and .anything's available now. .pizza, .shop, .whatever is all available now. I go to Life Church up in out of Edmond, and they are buying TV. No. Actually, does anyone know where TV is? It's out of Transylvania. LifeChurch.tv, the TV is actually Transylvania. But they have put in a request to be in charge of the .church top-level domain. So which means that anywhere in the world that wants to have something .church, they will have to go through LifeChurch. And the cool thing is LifeChurch said they will give it away 100% for free, except for the cost to maintain the name, which is, what's that going to be, 50 cents? A lot of people. The problem is there's another company that's buying up all these names. And they're both fighting over it, and there actually is basically a court battle, kind of. Who's going to get it? Is LifeChurch going to get it, or this other commercial company? Well, hopefully it's live church because you can imagine what the other place is going to charge. But it's an enormous fee. It's like $10,000 to buy the name, and then you'd be in charge of it. So you would actually become a top-level domain for .church. I like their point, though. They're going to let anybody have it. Like, hell yeah, if you're a church, you can have one for cost of the name, which is going to be cents. GoDaddy's, what, $8? And that's still excessive considering what it's actually costing them. But so, all right. Everybody okay so far? We covered like one slide. Doing good. All right. Here's a bunch of names. Okay. These are the ones we know. Okay. But there's more. There's a lot more. So now it's pretty much unlimited. You can get, the .pizza domain, or pizza.com was sold for like $10 million a couple years ago. I was like, boy, I was an idiot. Because way back when, I had dozens of domain names that I bought. Can you imagine if I had bought pizza.com? Even if I hadn't used it for 20 years. I would have paid $8 for it and sold it for $10 million. That would have been a heck of an investment. So, I don't know. It's crazy. But there's a lot of it. And all the two-letter ones, those are the countries. CC, US, TVs, Transylvania. People think it's because they're on TV. No, that's not because they're on TV. It's just because the world thinks that's what it is, but it's really Transylvania.
So it's run by Dracula?
Exactly. Okay, 240 country codes. Okay. I said all the two-letter are all country codes. Okay. CA is Canada, I think. CN is China. I can't remember. There's so many of them. RU's Russia, stuff like that. It's kind of nice when they had stuff like that. Like if I want to block Russia, I could block everything starting or ending in RU, which was kind of nice. But the problem is people in Russia make sites that don't all use RUs. Use .com, .org, whatever. And, because this list here, this is the way it was supposed to be. Like a .org is a non-commercial organization. Yeah, they're not all non-commercial anymore. Okay. I was an internet provider, so I was down here. Okay. So, but really, it's all the only one that's really kind of governed at all right now is .edu. Actually, I've never tried .gov, but for the longest time, Rose State couldn't even get Rose.edu because it said that for an edu you have to be a 4-year institution. So we used to be at rose.cc.ok.us. Actually, I wonder if that still works. Let's find out. It might. Where's our mouse? No. No, didn't work. But that's how you used to get to Rose State. And it was, KDewey at rose.cc.ok.us. So many people when I first started, they would type that wrong. Then we got rose.edu approved finally. So, okay. Okay, so they approved 240 country codes. Okay, there are restrictions. You can have a 253 character name. That's long. Okay. But I think the hosts never combined. But still, can you imagine your domain name is, that'd be crazy. Now we have that whole tiny URL stuff, like you'd have go.l or whatever, and basically you can give those really short, those tiny names. Y'all seen those? Like a lot of times you go to Facebook, you click a link, and the name's like really short. It's here. Let's look at one of those.
.ly sites.
Yeah. So you can go to tiny URL right here, shorten that long domain name. And I want to have my.rose.edu/faculty/kdewey. Okay, that's my name. That's my domain. Okay, I'm going to do this. Allow access. Now my tiny URL is this right here. Let's see if it actually works. Go to another web page, paste it in. Works perfectly. So what it did is it took my long domain name and shortened it for me. And you can actually track how many people go to it now. Can anyone think of any bad stuff related to that? Now I can take this very long, obscure URL in Poland, China, somewhere that's full of spam, You pass out a tiny URL name and people aren't going to know it's not real anymore. See, before you could look at the URL and you could read it. Oh, it says google.com, but it's really going to something else. But now we see tiny URL, like, oh, it's just a tiny URL. Yeah, but it could very easily go anywhere. Okay? So that's what tiny URL is. Okay? But any alphabet, including hyphens, underscores, periods, all kinds of stuff. No other special characters. Can't have ampersand, stuff like that, because that's used in the search terms. Everybody with me? All right. Host file. Host file is awesome. I'm going to do a demo of the host file for you. Okay? The host file is under C. Actually, why don't everybody open this up? Y'all sitting at the computer. Open this up for me. It's at C, Windows. I'll open mine and show you what it is. 32. Okay, it's under C. I mean, you can go to my. It's under C, Windows, System 32, drivers, etc. C, System 32,
Drivers.
no, keep going. Got it. Drivers, etc. Okay, everybody see that host file in there? Open up that host file. If that's what to open it with, open up a notepad or something.
It's called what? Etc.
Drivers, etc. Then you see a host file. C:\\Windows. Windows. System 32. Drivers. /etc. Right there, hosts. Open up that host file.
Oh, they got the IPv6 set up.
Yep. So open up the host file. Let me open mine. All right. I'm going to tell it to open up a text pad. Okay. And what this file does, again, it checks this very early in the name resolution process. So it basically says if someone's trying to go to rhino.acme.com, send them to that number instead. Okay? I'm going to put an entry in here with you. Okay? Everybody follow along here. For the put a line at the bottom. I want you to put in this number 66.210.163.130. And don't do anything else yet. Okay. 66.210.163.130.
Just put the pound sign in.
No pound sign in front of it. And I want tab over or space over or something a little bit. Let's put in www.yahoo.com. All right, so www.yahoo.com. Okay. Now, if you've already been to Yahoo, it's going to cause an issue, but let's see if mine works first. I'm going to save it. Now, if I go to www.yahoo.com, save your file, then go to yahoo.com. Save your file, then go to Yahoo.
What do I save it to?
Oh, just hit save. Just hit save. Save. Now, for any of you web browser, oh, you've already been to Yahoo. It's going to cause an issue. Oh, no, it worked. Okay, good. I didn't remember it. So that's not Yahoo. Y'all agree that's not Yahoo? That's actually the old company I used to run. That's their mail server. So what we told it was, remember I told you, it says first it checks to see if it is Yahoo, and it wasn't. And it says, have I been to Yahoo lately? Do I remember it? And I was worried yours, but okay, it didn't. Third thing it does is checks this file. And in that file it says, I found www.yahoo.com. And it goes right to that IP address. That's the one we put in. So you could do anything. You could do www.facebook.com and send it to MySpace.
a way to keep like parental controls on computers and
Yes,
stuff like that.
But there's a problem. Now go back in your browser, just type in yahoo.com with no www. Type in Yahoo with no www.
Oh.
It should come up. Is it? Oh, they're forwarding it across. Oh, okay, so it did work on Yahoo. A lot of sites that wouldn't have worked. The Yahoo, what they did, they forwarded it without an extension, without a host to the www host. They kind of cheated. But normally in that file, you'd have to put in yahoo.com without the www, yahoo.com with the www. You'd also do mail.yahoo.com and chat.yahoo.com and all the other stuff. Because a lot of times people go to saved links. Like say someone's already been there and they just click a link in the toolbar and it goes directly to, or www2.yahoo.com or something. So you need to put all of them in there. But yeah, you very easily redirected. So kind of cool the way that works. And there was a virus that did that. What it would do was it would wait until you typed in a known bank's name that it knew about, that it had a copy of. Then once you did that, it would go into this file and put that bank's name with their IP with the fake IP address.
And people are putting in their own IP.
Right, and you don't even realize it. I'm going to yahoo.com. I have no idea I'm not at yahoo.com. Isn't that what it says at the top, yahoo.com? I mean, on the address bar? Because you don't know. So that's why it's scary. Some antivirus programs actually go into this file and put a bunch of those spammer sites in there, which are good. That way, even if someone corrupts their DNS, this file is still checked first. So it's kind of cool. So that's the host file.
So a buddy of mine who works for Microsoft, and noon every day, if what Microsoft employee goes to google.com, that automatically directs them to a page that says, should you be using Bing?
I don't think any of you know Josh Posey. He's a prior student of ours. And all he did was Reddit and Failblog and all that stuff. Well, we, on our servers upstairs, we made a website that said, Josh, get back to work. And we went to all the machines in the lab and put a redirection for Reddit and Failblog, all those to that website. Said, Josh, get back to work. And it was the same basic thing. And what's funny was he didn't know how we did it. I mean, dude, you've been through our classes, but, you know, think about this, though. I'm telling you this today on September 25th, 2012. A lot of you are just starting out. 2 years from now when you graduate, are you going to remember this? Maybe, maybe not. But hopefully, like, I heard of that before, then you can look it up. But he's like, I have no clue what you did. So what he would do is he'd go find other computers that we hadn't put it on. It's like, not a big deal. All right. So let's talk a little bit more about what we just did here. Okay. Comes with a host file. Associates IP addresses with host name, just like we did. Done. You can do that at home. Put in whatever you feel like. Just make sure if you can do Facebook, you put in facebook.com, www.facebook.com, mail. Go to Facebook and see what all the URLs are. Look on the address bar. Don't worry about the extensions. But I mean, just look at the beginning, like mail.facebook.com, chat.facebook.com, whatever.facebook.com. And put them all in there.
Can you do a wildcard and do
I
star.facebook.com and see if that...
Actually, you might be able to in here. I'm not sure if you can or not. I don't know if you can. If you can, that'll be awesome. Okay? So, matches up one by one, name and IP address, alias. You can also do nicknames in there. But the reason they had this, because before we had full DNS everywhere, I mean, you could make an alias in there that said file server. Because you, as a user, you could remember file server. So you just type in file server. But the alias would then redirect you to where you're really supposed to go. Okay? All right. Unix base is called hosts. It's in the Extended. Okay, yeah. It's in the Extended directory. Windows, it's in the Windows System 32 drivers, etc. I have no idea why it's in there, but that's where it's at. It's kind of deep. Okay? I know where they get the etc. from because that's what it is on the Unix system. And believe it or not, Unix was here before Windows. Okay? All right, so... Everyone okay with that? It's kind of cool. You can do it on any other file system. Do it on Mac. Mac is Linux, in case you didn't know. It's running on FreeBSD or OpenBSD, one of them. So. Just missed an awesome thing we did. It was awesome. These guys are amazed. They're so quiet. They can't even talk. They're so amazed. Okay. Here's an example of it, even though we just did this. Basically, we're saying these hosts go to these addresses. And we can also give it an alias. So if we had this in our system, if I just typed in web, it'd go right here. If I typed in FTP, it'd go right there. And so on and so forth. So, would it be a good idea with this to speed up your computer at all?
Yep.
Actually, it would. Do y'all remember, what year was this? When we were using dial-up and like, what was that free dial-up? It wasn't Netflix, but it was a dial-up service and something.
Netscape.
That was a browser, but what was the dial-up service you got? Kind of like CompuServe, AOL, then there was NetZero. That's the one, NetZero. Well, they had NetZero, and there was, I don't know if it was NetZero or a competitor, they were talking about how you could surf the web 3 times faster. And they actually had 2 computers on dial-up, and sure enough, one would serve it 3 times faster. Well, what it did was, when you surfed the web, it made this file. It remembered everywhere you went. So it says, he just went to Cengage.com. So it made a file for it. So the next time you wanted to go there, it didn't have to. Remember how I talked about DNS? How we got to look for the root server. Then we got to look for the top level. Then we got to look for the second. So I could be making 5 phone calls trying to find out where it is. Or if it's in this file, do I have to call anybody?
Is that what your cookies do, though?
Yeah, that's the reason they were originally there. But still, you still have to go out and see if the records have been updated. So the problem is a lot of records will expire. I said they usually set to about 3 days normally, 3 to 8 days. And like you go to a website sometimes, like you might go to msn.com, it might load 30 or 40 other websites because all those ads and stuff on it and all the statistics. So if you can put all these entries in here, you're really speeding. Were you really speeding up the internet? No. You were speeding up the name resolution process. You were making this file. But there's a bad thing. Say we went today and we, did like we did. We made Yahoo go to that other thing, but the IP address changed. Or say here, Cengage changes their IP address. So I don't care what you do, and the problem is people don't know about this, and you could be calling the help desk and say, hey, I'm trying to get to the website and it's not working. And they'd be like, what do you mean it ain't working? It's working for me. And you could be over here, and they have you type it in, they have you reboot, and it won't help because this is hard-coded. And since it's hard-coded, it will never, ever get updated. So it's an issue. That's why it's not used anymore. But if you're aware of what it is and you want to speed up your stuff, you can do this. But just remember, it'll never get updated unless you manually do it. So, okay? All right. But it also has the IPv6 stuff in it. All right. DNS is hierarchical. Okay? I used to have a video on it, but I lost it. So I can't show you the video. It was kind of flaky anyway. But okay. Associates a name with a number. Okay? DNS refers to the application layer service accomplishing the association of the name to the number. Okay? So it's an organized system of computers, database, making it all work. Kind of what we've been talking about. The root servers, the top level, the secondaries, and so on. Okay? There's redundancy. There's 13 root servers. Okay? Actually, I might be able to show you one. Hold on. Where is it? I'm going to show you what a DNS server actually looks like. I hope it's on here. Come on. Okay. Give me a second, I'll have it in there. Come on. administrative tools, DNS. Okay, this is an actual DNS server. So when we in this classroom type in an address, it actually asks this server for it. Okay. Now on here, we're in charge of a few domains. Okay. So when we type in something.cyber.rose.edu, this machine goes, hey, that's me, I'm in charge of it. When you type in Rose Lab, stuff like that, we're in charge of it. But other than that, it doesn't know what to do with it. I'm going to show you how to look at that. Okay, there's something called root hints. I'll make this a little bigger so you can see it. These are the 13 DNS servers. They're called root hints. Basically, if you are trying to go somewhere your machine has no clue about, that's one of these guys. These servers are all replicated worldwide. They're identical. I would say 11 of them went down with no issue, which is absolutely amazing. But here's where they are. When I worked for an ISP downtown, we actually bought out Galstar Systems up in Tulsa. They used to be one of the root servers. So yeah, their DNS was crazy. It was nuts. There's all the IP addresses of them, and wait, it was like Windows 2000 server, some version. When you install DNS, it would lose these. They wouldn't be there at all. And it kind of sucked was because it wouldn't work. And then Microsoft, and there was a known bug, but they hadn't come out with a fix yet, so you had to go get the cache file. And the funny thing is, DNS said it all relates back to the original internet, which was all Unix based. So all this you're seeing right here is nothing but a Windows interface to a text file. I'll show you what they look like. Okay. Okay. What? Did I type it wrong? Let's see, Windows. All right. I know it's hard to see, but this is the actual text file for that root hints tab. Okay? Root name server hints file. All we were doing was looking at a GUI interface. The cool thing about DNS, it really doesn't care what platform you're on because it still works in text files. The windows will just transfer back and forth. But there's, the F, the G, the H, the I, the J, and there's all their entries after it. So it's kind of cool. Remember we talked about IPv6, how it's starting to be implemented? There it is. There's the IPv4, there's the IPv6 address. So it's starting to be implemented already. So our systems are going to be ready. But yeah, all this is done through text files. Windows just gives us a nice little GUI interface to manage them. And it does part of it wrong, but it's okay. It still works. All right. And if I go into, let's see, where'd they put the other ones at? The other one's stored in Active Directory. All right. That gives you a clue. Like we're in charge of cyber.rose.edu. That's us. Okay. Here's all the hosts we manage for that. CM and FS and LM and VC. Some of you used the virtual lab before will notice VC. So vc.cyber.rose.edu actually goes to that internal IP address. So yeah, we manage all this. That's just what it looks like. Okay. Leave that up in case we need it again. Okay, so there's many computers worldwide. They all work together. I said there's 13 root servers, and they work quite well. All right. Oh, and it says here how they are the ultimate authorities. That is, it's kind of like the level 13 of the help desk. When you get to the guy who knows everything, that's what these guys are. So if you're trying to get to a website that no one has any clue, you've never even heard of anything about, like the very first person that tried to goes to a .church or a .whatever that's finally implemented, they're going to ask these guys, hey, who's in charge of that? Then these guys are going to say, oh, .church is now Life Church, so go talk to them. then they'll forward you on where you're supposed to go. So they're the ultimate authorities. All right, 3 components. We got a resolver, a name server, and namespace. Let's talk about each one of these. Okay, I go into a whole bunch more depth in another class, but this is decent. Okay, resolver is any host or internet needing to look up a domain name. So that could be you. You need to resolve it. You say, hey, I want to go to www.zombo.com. So you need to resolve the name. So any host on the internet need to look it up. Okay. Then we have the name servers, a database associating names and IP addresses, like I just showed you. Okay. Provides information. So when you type in something in this room, it goes through the network up here. It goes down to that server down the hall, which I just showed you on the screen. And that server says, first thing it does is, okay, am I google.com? No, I am not google.com. So it sends out the request. If the machine was just rebooted or its memory was cleared, it would go talk to one of the 13 servers. But once it's already talked to them, it knows where .com is. It probably even knows where Google is now because so many people go to it. But if you were the first person on campus to ever go to Google, you would have had to do a little more work. So, the database of all that information provides information to the resolvers on request. So that server sits there and does nothing all day long. It's waiting for you to ask it something. Okay. The namespace is the abstract database of internet IP addresses associated with their names. Basically, is how it all works. Okay. Describes how the name servers share the information. They're all linked together. The DNS namespace is huge. It's kind of like the telephone operators from the past. Remember them? We had to call, hey, I want to talk to so-and-so, and they'd connect you. That's what DNS is. Same thing, but automated. All right, here's our little picture. See if last year the picture sucked. See if it's any better. So our client says, what is the address for www.local.gov? Okay. The client, first of all, which they don't show, it actually looks at itself. It says, am I? Well, LLC.gov? Nope. Have I ever been there? Nope. It's not my host file, so let's ask somebody else. So we're skipping all that first part. Obviously it does it because you guys saw it. It looks at the host file first. So it goes to the LAN server. It says, what's the IP address? The LAN server says, what's the IP address? Okay? He doesn't know, so he sends it on to the ISP. So if I don't know down the hall, we actually use Google as our next level our DNS server. Like at home, you all have your DNS at home. You get one from your provider, probably Cox or AT&T or somebody. I go in and change that stuff. Don't use theirs. Theirs suck. Go in and change it to 8.8.8.8.
I've been like that for a while.
Yeah, it's so much better. Because the problem is, it would be so many times people come and say, Ken, the internet's down. No, it ain't. I got it. Trust me, the internet is not down. Physically impossible for the entire internet to be down. I can't get nowhere. Oh, that's a DNS issue, obviously. The entire internet's down for you. Either your connection's off or something. Actually, our secretary came in yesterday morning, was all upset. She goes, I did my homework Friday night. I woke up Saturday morning, my internet was dead. She has a phone, smaller than this. She goes, see that little screen right there? That's how I had to do Facebook the entire weekend. She says, I was on the phone for 2.5 hours with AT&T and they couldn't fix it. Like, did you reset your router? Well, they had me walk through everything, and they couldn't figure it out. So did you, unplug it, play it? She goes, well, they had me do all this stuff, and they finally gave up. So now they're going to have to charge me, send me to another level to get it fixed. I'm like, did you, unplug it, plug it back in? She goes, no, they never had me try that. So she calls her daughter when she got out of school. Unplug it, amazing, and fixes it. She's like, why didn't they have me do that? I'm like, you got me. I mean, that's always step one.
Yeah.
Have you reset the whatever you're doing? But
my mom did that with her phone. Her phone wasn't working. She's like, I can't figure out what's wrong with my phone. So she went and bought a prepaid phone. I'm like, did you
turn
take
it
the
off?
battery out
and restart
let
it?
it sit for 15 seconds? Or no, I don't know how to do that stuff. I'm like, you just take the battery out. And she's like, oh, it's working now. I was like, see?
Yeah, so many people don't realize that. But
I was like, you always disconnect the power source from whatever you're doing
right.
and reconnect it and see if that works.
But Cox a lot of times will go down. So people call me and say the internet's down. No, it ain't. Well, an easy way to tell if the internet's down, you know that number I had y'all type in there? If you can just remember one number, I don't care what number it is. Because if you can type that into your browser and it comes up, it means the internet's working. I mean, because we're bypassing the whole DNS thing. If you know a number, just like the one I gave you to type in there, Because if you know one number and it comes up, you know the internet's there. You just can't get the naming part to work. So, but a lot of times if Cox or somebody's DNS goes down, the internet's down. That's what people think. But if you go in and dump their DNS and start using Google, which is 8.8.8.8, and the secondary is 8.8.4.4.
It's so much faster.
It is. It's awesome. So much better. And yeah, so you need to put that in. That's Google's, and I've never had an issue with it since then.
Where do you put that in now?
I'll show you.
They have a tutorial deal on it. It's like a small paragraph on Google how to do it. It's really easy.
It's really simple. Okay, but I'll do. This is Windows 7, so if you want to see how to do it, follow along. I mean, let's do it on yours. Everybody go to Control Panel. Click on Start. Go to the Control Panel. Click on Start. Go to the Control Panel. Okay, and inside the Control Panel, go to what did I do? Network and Sharing Center. What did I do? I hit something. Okay, hit Network and Sharing Center. Okay, everybody got Network and Sharing Center? Then top left corner, go to Change Adapter Settings. Second one on the left. Change Adapter Settings. Okay, now this is where it could vary. At your house, you got to find which one's enabled. Because you probably have two. Like if you have a laptop, you can have a wireless and a wired. So find the one that's connected. See how that's disabled, not connected, this one's connected? So go to the one that's connected. Right hand click on it, go to Properties. Right hand click, go to Properties. Okay? So I right hand clicked on my adapter, went to Properties. Everybody got this screen up? Go to IPv4 Properties. Click on IPv4 and then click Properties. Okay, comes up with this. All right. There's one exception to this rule. If you're on a domain-based system, like at your work, don't do this. You're going to have an issue. Don't do it in here either. It'll cause an issue. We do it on our end. Okay? But if you're at your house, go in here and click Use the following DNS. I mean, you can do it here. We can always undo it. But do this. Click Use the following and type in 8.8.8.8 and 8.8.4.4. At your house, do this. If you got a domain, don't do this. Type in that right there. So what's happening is we're getting our IP address automatically, but we're using Google as our DNS. Now, if you have a router at home, you can just hard code it into your router. If you know how to get into your router, go to the setup of your router where it shows your IP address from whoever. You can put it in there. Then that'll automatically do it for everybody. Okay? I'll show you. I'll see if I can find one to do that. Everybody okay on that? Hit cancel. Don't save these.
What was that number again?
8.8.8.8.
8.8.
8.8.8, and the next one is 8.8.4.4. Okay. Now I'm not going to save this because I don't want to screw these up in here. Let me see if I can find another one. Oh, I don't know the address.
Public DNS server.
I want to go to a router.
You could ping.
I can't get to mine.new. Oh, heck. Hold on. Aha. Hopefully this works. We're trying. Come on. Trying. Their router needs to be rebooted every now and then. And it's that time, I think. Oh, there it goes. Okay. On your router, this is a Linksys router at home. Well, I mean, like you have at your home. This is the connection they have to Cox. Just under here, put in Google. What I do is I put in Google as the first one. Then whatever Cox has, maybe second or third. That was going to try Google first. But for some reason, Google's not working, which I've never had happen. Then it's going to try Cox. But if you ever call Cox and they walk you through this, they're like, oh, no, do not put Google in there. Put us in there. Now, bogus. Put Google in there. It's better. So static DNS1, put in the 8.8.8.8. Now, if you do that on your router, you don't have to touch your machines at all, because all your machines will automatically get all the information from your router. Okay? All right. So, back to this. Take 20 minutes per slide. This is not going to ever finish. Okay. So the client asked for this website. Asked its own DNS server, and its DNS server says, that ain't me, I have no clue. So it sends it to its ISP. Hey, what's the IP address of this? And again, each one of these servers, first thing it's doing is says, is that me? No, it's not me. Have I ever been there? Do I even know anything about it? Nope. So then if it doesn't know, it passes it on. So it gets all the way up to the ISP's ISP. And sooner or later, if no ISP knows about it, it asks the Big Daddy. It says, where is this? It says, the address is this. Okay, and it's not really how it works. So if the picture sucked last year, it still sucks this year. Okay. Really, what's happening is it forwards it over to the .gov machine. Then the .gov machine does the rest. Okay. Then the gov machine forwards it over to the LOC server, which then resolves it, and then sends it all the way back down. But they kind of left that part off. Because you don't, can you imagine if the root servers had to know about every domain, every host? No, they can't. They can't. It's like, they can't. It's just too much information.
It's like trying to catalog the internet.
Exactly. So what they do is they know who's in charge of .gov. And they say, oh, there's .gov. Go talk to Daniel. Then Daniel says, okay, so I'm in charge of all of .gov. Oh, you want to talk to LOC? Oh, LOC's over here. Talk to this guy. So then each time what's happening is it's passing it back to this guy, and it's doing what's called a recursive lookup, that once he talks to this guy and he says, oh yeah, I'm in charge of LOC, and it's such and such, then he returns it back down. But they're missing that whole middle part in that picture. Okay? All right. Now let's talk about some of the different record types. Okay. DNS resource record. It says describes one piece of the database. I don't know if you noticed a minute ago, but we had some A records. There's some host records in there. Those are entries. That's a name and a number. Okay? So you have an A record or an A with an IPv6. C name is a canonical name, which is also the same thing as an alias. Like www.google.com is an alias for www.l. Actually, I think it is. Let me make sure. Actually, it's not. Hold on. Naturally, none of these are. Okay, there it is. Yeah, look. I told it to find me www.yahoo.com. And it really basically said, well, that is really ds-ne.fp3-real.wa1-b.yahoo.com. The hell kind of name is that? Okay, and the alias for that is that. So we know it by the short name, the canonical name, or the alias, but it's really this stuff. Those, whatever the naming convention is. Okay?
Can you tell us the alias for, like, if you did a tiny URL?
No. No, it will not. Because the problem is with NS lookup, it can only tell us up to the dot something. You can't get the slash this, slash that, slash the next thing. For finding out what a tiny URL is, what I do is if I'm ever really skeptical, I put it in my phone. My phone is not going to get a virus. An iPhone, obviously. It's not that Android crap. You don't have to worry about it.
I got an antivirus.
I don't need one. Or open up a virtual machine. I actually have virtual machines. I've used that before. For a while there on Facebook, I did that Farmville thing. I had to win, by the way. So I had this most awesome farm. But you could get extra stuff by clicking on links and doing stuff. So I'd create a virtual machine, click on all this stuff, install all these toolbars and stuff, get all these points, reboot the virtual machine. Click on a whole bunch more, reboot the virtual machine. So I never got anything on it. Because all they cared that you installed it. It doesn't have to be on your PC. So, yeah. But No, a lot of times I'll click on a link on my phone. It's not made to infect your phone. It's made to infect your desktop, and it's not going to do it. All right, so we got canonical name, which is just an alias. Okay. Then we also have MX. That's a mail exchanger. If you send mail out on the internet, say I type an email and hit send, what happens is it does the whole DNS thing again, but says, hey, this time I'm not looking for an A record. I'm not looking for www. I want to know where to send mail to. So it's looking up a mail record. It says, oh, mail, she's in charge of mail over there. So DNS keeps track of everything. Host records, aliases, mail, everything. Also pointer records. Your pointer records are the reverse. And whenever you use reverse lookup for a phone number, I used one the other day. This number keeps calling me during the day. Actually, you should call about 9:30 in the morning when I'm at the gym, so you usually don't get it. But they never leave a message, so I typed it in on the internet last night, just the number, and did a reverse lookup, and it was some company trying to sell something. But this is kind of important, because nowadays with the internet, it does a reverse lookup. If I type in, like say I'm getting mail from someone. Say I'm getting mail from Daniel, wherever Daniel's at. It says it's coming from Daniel at gmail.com. Okay? Well, I look which address it came from, the number that it came from, and I said, okay, I got the number now, so I do a reverse lookup on the number, so is that really gmail.com? It prevents a lot of spam that way. Basically says, okay, you're saying you're coming from Gmail? You're not coming from Gmail, then I dump the record. So there's a lot of ways that things can be used. Okay. Some will still deliver anyway, but I mean you can get really particular with DNS and mail. You can basically say, you know what? I know some of the mail servers won't even let you use aliases. Now how we just had an alias for Yahoo, you can actually set up a mail. No, it needs to be one name only, no aliases. That way there's no one screwing with it, and it's just really tricky. Okay, we have time? Jeez, I'm not going to finish. Okay, configuring them. With large organizations, we have multiple name servers. We have 3 here, I think. Just in our cyber lab. We really don't need 3, you need 2. You always want to have 2. I mean, if you ask Microsoft and you're building a domain, you ask them when should you get your second server? When you had your first user. I know it might sound weird, but you always need a backup. And if you got your entire domains running on one machine, what happens if it crashes? Everything is gone. If you got 2 servers, okay, fine, I might have lost some files, but at least I didn't lose the entire domain. I didn't lose the entire DNS. I didn't lose everything, because it all replicates. Okay? Okay, you have a primary and secondary, ensures connectivity in case one goes down. Okay? It says DHCP service assigns them automatically and can add them in DNS automatically. You can manually configure them, kind of like we were just looking at. They tell you how in the book. Okay. The number of pages aren't the same. Sorry. They're using website hosting. DNS is very critical. If you screw it up, you're done. You take the entire internet down. Because how many people are going to remember a number for a website? I know like one number. So I use that one all the time. And it's good. It's just a login for a mail server. Okay? Okay, the process. The service provider runs programs on the user computer, notifies the provider when the IP address changed. The provider launches a routine to automatically update the record. What they're talking about here is dynamic DNS. I guess I can show you mine. Come on. This is free, by the way. Okay, this is a free service. What I have is I have some names here. I have Dewey.mine.new. I set up Slagles.mine.new this weekend for a friend of mine. And what happens is, this is my friend's house. I set up his wireless cameras this weekend. Okay? Who wants to remember that? You don't want to. So I set up Slagles.mine.new, goes to that number. And the cool thing is, if his router, if it ever detects a change in his address, it'll automatically update it. So dynamic DNS is dynamically updated. It's updated by your router, Your camera, that camera on the wall could actually update automatically. They can connect in, like we have rosecam.mine.new. That's why there's no E in it. I was trying to connect in this weekend, wouldn't work for nothing. There's no E in it. I thought I had cam. No, I thought that was an S, like Rose Cams. But yeah, this service is free. You get like one host for free. But back in the mid '90s, I donated $20 to them. I have unlimited, and I've never wanted any more money from them. I'm like, sweet. So I have the pro service. Okay, but it works good. So if you ever need just a name to a number, I recommend you can use this for your house. That way, like I connect Dewey.my.new all the time. I just picked mine.nu because it's short. There's like a ton of them. If I was going to add a host, they give me a list of domains to pick from. I can be anything. HomeFTP.org, whatever. Libertanian? IsAlawyer.com. You can be IsAlawyer.com. There's tons of them. Okay. Stuff for sale. But what it is you pick the name at the beginning. So I could be Ken. Oh, there's mine.new. That's the one I use. And it's free. I mean, it's awesome. Okay. Oh, savesthewhales.com. Well, there's readmyblog.org.
I'm just surprised that one's not taken.
Oh, what it is, they bought the name. Then you just pick a host for it. And if the host is not in use yet, they give it to you. But mine.new really doesn't mean anything, so it's not Save the Whale, but it's short. And I always use it for everything, and it's never taken. I've never, ever had them come up and say that name's taken. It's pretty much the shortest one on the list. At least when I first made it, there was only like 4 or 5 back then. Yeah, there's not many on there. Not many short ones on there. Oh, there's a is-buy.us. Oh, buy. Oh, okay, we'll move on. Yes, I finally realized that one. I'm like, oh, that's nice. Okay. Funny story about that. We had a guy, someone a bunch of us know here, we had suspected something that, okay, he likes pink shirts, you know, but he's not a real man that can wear a pink shirt. His computer broke. Oh, yeah. But his computer broke, and he wanted to get all his data back, so he brought it to me. Oh my God! Everybody's like, "You gotta look! You gotta look!" We have confirmed the suspicions. It's like, ding ding, it's true. All this stuff we've been thinking about all these years is pretty true. So, okay, but dynamic DNS is a really cool service. Okay, it runs on your device, your router, your camera, your whatever, and automatically updates. That way you can use it. Okay, and it, you know, basically it happens instantly. You can add a name and it's there instantly. If your name changes at your house, this changes instantly. Not instantly, but very quickly. Because your ISP could change your IP address at any time. Your router, your Linksys router, has a dynamic DNS tab. Put the information in there. If your router ever gets a new address, it will automatically update it on here. Until you as a user, you'll never know the difference. SBC Yahoo DSL, I don't know if y'all remember those. That was the only one I've ever seen that could like change 5 times a minute. It'd be like, what the heck? It kept changing every second. So I set up dynamic DNS. And what they do is they set the resource records to expire in seconds. And it works great. That way, if it keeps changing, it does it. It's not a DNS replacement, but you know, for large, big organizations, it ain't gonna happen. Like you wouldn't want, you know, whatever those names were for rose.edu. That wouldn't work. But it's good for home users. Okay. All right. It says additional protocols. You can have TCP or UDP. Those are the 2 protocols that work over IP. Okay. It translates the request into usable format. We have HTTP. You know what that is. You have DHCP, which is Dynamic Host Configuration Protocol. We talked a little bit about that. That's where we get to our addresses automatically. We talked a little bit about that. Okay. We have Telnet. How much do I got left? Let me see. Yeah, I'm almost done
6
here.
more slides.
How many? 6?
6.
Okay, we're going to finish. Telnet, Terminal Emulation Protocol. It was used a long time ago to log into servers. You can still use it to log into routers, but it's really not used much because it's unsecure. Okay. It's a terminal emulation. You would connect and you would do stuff. It actually sent everything in duplicate. So if I typed in Ken as my username, it went in as KKEENN. So I actually captured the data to look at it. It was kind of weird. Okay, but you can connect Windows to Linux. You can do everything. It's still on all our systems. It's pretty much disabled now. Notoriously insecure. Okay. FTP, file transfer protocol, still used today, but it's very insecure. It probably says that somewhere. Okay. It just doesn't. Now they have SFTP, which is secure FTP. They also have SSH, which is the secure version of Telnet. But FTP allows us to transfer stuff, and we're going to walk through a little demo of doing this here next Tuesday. Y'all know I'm not going to be here Thursday. Y'all know that? Tuesday we're going to walk through a thing on this. Okay. So all these little stuff we're going to do each one. Okay. TFTP, trivial file transfer. You use it in routing a lot, doing a routing class. Basically, you say, the FTP makes a connection, then you tell it what to do. Give me a file, put a file, stays the connector for a while. With FTP, it basically says, connect, grab me the file, and return. That's all you do. Okay? Connection, it connects to it, grabs it, and then you're done. I mean, there's no big old session where it stays logged on forever. It says it's connectionless, okay. Doesn't guarantee it. Okay. It's used pretty much for updating routers. That's about all it's used for. I don't know anything else it uses it. Okay? NTP, Network Time Protocol. Used for updating time. Very critical on networks. You want the time to be updated. Okay? Alright, benefits, UDP, it's quick, so it uses UDP. Connectionless. Time synchronizing is important for everything. Had a big issue I teach at another school, and they were complaining I didn't respond to students in time. And I was pissed. I was so pissed Monday. Oh my God, I was going to shoot them. I sent big old email to them, and then this morning I did it again. Then I told them, there was something wrong with your time, and I had proof. Back in early September, there was an issue with the time, which I remembered. Took a picture of it, which I kept. Thank God I kept it. A student posted a post on the website, and I replied to it before he posted it. How can that happen? So I kept saying it was a problem. I said, you need to go look, because I did that. They're saying I didn't reply in time. Said there was an issue with their clocks. No, there wasn't. Yes, there was. I made the phone call, and I said, you look in the records and see where I called, and I had that picture, and I sent it to her. I said, look, how could I possibly have replied to the student before he asked me the question? Then I got an email back about 10:30 this morning. I believe you. All that crap she's telling me is bogus now. Good. I was pissed. They said I wasn't doing my job. I said, oh. All right. Sorry about that. Time's very important, though. Obviously, it can cause issues in teaching class, too. Because I have to reply within so many hours on that other school. I mean, they are like, man, I have 48 hours to grade an assignment, 24 hours to answer a post in my office area, 48 hours to read an email. Row State, they don't care if you reply for 6 months or grade something 3 months later. Okay, time's very important. Ping, packet internet groper. We'll play with this some more, but it's testing connectivity. We did this a little bit when we did our little hands-on for Chapter 2. It allows us to connect. Hey, are you there? Is what we're basically doing. Okay? There's a bunch of different replies, which we'll talk about a little bit more later on. Okay? Okay, and there's an example of it. We just say, hey, ping that address. And it says, he's there. It tells us how long it took to get there and how many hops it took to get there, the time to live. We talked a little bit about that before. We'll mention that more as well. And that's the end of Chapter 4. Yes, and we have 30 seconds. All right.